Good afternoon, everyone. My name is Catherine Strong, and I am a data and reporting product manager here at Index Exchange. And today I'm joined by my colleague, Raman Sarvaria, who is a software engineer also on our data and reporting engineering team. We are here today to give you all a bit of a background about how we are using Vertica as our primary engine for big data and how we are bringing transparency to advertising in the digital media space through data. When you think of big data, you may not necessarily jump to digital advertising or journalism or how they're connected. To give you some context about what we do at Index Exchange, we are a global programmatic advertising exchange that helps premium publishers like the Globe and Mail sell their advertising space in real time. While advertising online can sometimes be a little bit of a taboo, it's actually really critical in supporting journalism and independent media, because without advertising, many of our favorite content providers would cease to exist. Here's an example of some of the great publishers and digital media companies that we work with today to help them monetize their advertising space. One of the main reasons that I absolutely love working at Index is because I know that we are helping media companies survive and to thrive. Today, about 70% of advertising dollars in the entire world are spent on the big tech giants, often called walled gardens in our space. And even though only about 40% of time spent on the internet are on those big tech platforms, we at Index Exchange are on a mission to reroute those dollars back to publishers in order to support journalism and independent media. So you may be wondering, how exactly does programmatic advertising work? I'm going to give you a little bit of a one-on-one of how programmatic advertising works and one of the reasons that our data volume is so high and why Vertica is such an important part of our big data equation. On the slide here, we have an example of the transaction chain from the agency budget to when an ad is actually served to a user on a page. So to start off on the left-hand side, brands like Lululemon work with agencies to develop an advertising strategy, and part of that strategy is called programmatic advertising, what Index Exchange does. So in order to facilitate this automated ad buying, agencies use tech-enabled buying platforms called demand-side platforms, or DSPs. The one in this example is the Trade Desk. Then DSPs bid on ad space from auctions run by exchanges or SSPs like Index Exchange in real time every time a page loads on the internet. The highest bid of the auction wins, and the Lululemon impression is served to the user on the publisher's page. So you can imagine throughout the internet, every time a page loads, we are running billions of transactions. To give you a sense of scale, here's a chart that I pulled this morning showing the 7-day rolling average of auctions throughout this year. We process over 100 billion auctions per day. And as you can see, we are continuing to grow. You can see here around March, when coronavirus started spreading in the United States and Canada, we started to have way more people online and were forced to adapt quickly and have continued to scale up since. This presents really interesting data scenarios that we need to accommodate for, and I'm going to hand it over to Raman to dig into the details there.
Hi, everyone. I'm Raman Sarvaria. I'm an engineer here at Index Exchange, or IX for short, and I have the pleasure of talking a bit about our data. Now, what's a big data TO talk without first going into our data and scale? We are in 8 data centers strategically positioned around the globe, which are running 6,000 plus exchange servers, or ad servers running auctions. From these auctions, we end up with around 100 terabytes of telemetry data collected each and every day. Of that 100 terabytes, that's about 140 billion auctions, or 1.1 trillion bid requests to DSPs for those auctions. After flowing through our pipelines, we end up with around 20 gigabytes of heavily compressed and aggregated reporting data. A little bit about the agenda. We'll be going over our pre-warehousing architecture, some product needs, our current architecture, a bit about our warehousing. Why did we choose Vertica? What's our cluster look like? How do we load the data into that cluster? And how do we maintain that data? Then lastly, we'll go over the future IX architecture. To start off with, architecture before Vertica. This is a bit much to ingest in one slice, so we'll first zoom into the different parts. To start off with, we have our regional data centers. These data centers run thousands of ad servers, which run billions of auctions. From these auctions, we see the previously mentioned 100 terabytes of data stored to the nodes. Next up is our ingestion cluster. We're running ACA jobs on dedicated nodes to ingest that raw data and stage it into our HDFS cluster. One thing to note is the regional data centers are global, and the ingestion cluster is moving all of that data into our Toronto data center. This leads into our Hadoop cluster. This Hadoop cluster really is the heart of the reporting at our company, and our processing is powered through Spark Scala jobs. These jobs are doing everything from cleaning to transformations, aggregations, creating custom one-off reporting jobs, and more. Underneath this processing layer, we have our storage or our HDFS cluster. This will contain our raw logs, our intermediate data, as well as our finalized data sets. Lastly, we have our reporting slice. We have two product offerings for this between our client audit logs as well as our visualization platform. Our client audit logs are log-level granular data sets which act as receipts. They provide transparency to our clients in order to let them know exactly what has happened within auctions. On the other side, we have our visualization platform, where it is actively ingesting our aggregated data sets and creating visuals for it, but it also supports custom reports being built on top of our data. So it's kind of a two-in-one platform right now. There's a few product needs for Vertica. The first is we want to be able to control our own data again. These aggregated data sets, we want to stay on our metal within our infrastructure. Secondly, we do need to bridge that gap between that visualization platform and our client audit logs. One thing we want to be able to do is add SQL access to these aggregated reports. And to do that, we need to add this data warehouse in between. Additionally, we want to add a way for our customers to automate and schedule the reports on their own. And then lastly, we really do want to build and track insights on usage patterns for our data. Here's the architecture with Vertica. As you can see now in the top right box, we can provide SQL level access to our aggregated reports for all of our IX employees done using an LDAP integration with Vertica. Additionally, underneath, we're actively working on a new solution which will be provided for internal and external clients layered on top of Vertica. This solution will create custom and configurable aggregated reports and can be shipped to our clients at multiple target locations, such as S3, SFTP, small file emails, and more. And lastly, this would enable us to move away from that visualization platform and kind of take our data back. Okay, how did we get here? How did we choose Vertica? Well, it started off by considering a multitude of solutions. From these solutions, we then opted into testing 3 of them: Domo, Snowflake, and Vertica. In these proof of concepts, we created multiple AWS cluster sizes, as well as a set of load and read queries. For each solution, for each cluster, we ran that set of queries. In essence, we did a performance comparison. And then we decided on Vertica for 3 final deciding factors. 1, the performance was within our service level objectives, and both Snowflake and Vertica performed much better than our existing solution. Secondly, we had to ask the question of, do we want it to be running in the cloud, or do we want it to be running on-premise? And honestly, our company truly does believe in, own it ourselves, and protect our data. There's 2 key benefits of this. The first, it enables us to be truly efficient. We know exactly what's happening where in our infrastructure. And secondly, we can decrease the number of barriers that go into troubleshooting. There'll be no more external support tickets in order to unblock our clients. And with this, Vertica was the only one of these solutions to support an on-premise cluster. Lastly, the licensing cost model, as well as the fact that we'd be able to run our own metal inside of our own infrastructure, resulted in significantly lower costs. Here's that cluster we were just talking about. We're running 3 clusters. We have production, staging, and development. Within our production cluster, we have 120 machines, which span 480 terabytes of disk space, 2,400 cores, and just over 15 terabytes of memory. We're a very CPU-heavy cluster in comparison to disk, which means that we actually prioritize heavy encoding and compression in order to save disk space. Additionally, we're running a RAID 5 configuration on the disks, specifically for striping for performance, as well as parity for redundancy. This is a very zoomed-in version of our architecture, specifically around the Vertica loads. We have our aggregated data living inside of our Hadoop cluster, and we're running an hourly job through Oozie, which loads that data into Vertica. Although the arrows flow through the data loader, we're actually leveraging Vertica's built-in copy loading. And what this does is it handles the threading as well as the distribution of the load across the Vertica cluster when pulling the data from HDFS for us. Through a hybrid approach in a JDBC connection, we trigger that pull from HDFS to Vertica. There's one thing I will mention about this. If you're using Vertica's built-in copy, we would like to suggest that you use a rejected table. And this is because, say for example, your load fails due to a bad record. That record, as well as the reason, will be stored in plain text on the disk of that node in something called the copy error logs directory, which means that you can, over time, continually accumulate this disk space usage. And for these rejected tables, they are session temporary, so make sure that you have a persistent schema and table involved. So when you see that this session temporary table has some entries in it, you can just quickly transfer them into your persistent table and you can keep track of those failures. In terms of our actual application loader architecture, one thing I will note before we talk about this is the loader is barely using any resources at all. It's primarily CPU idle, and this is because of the fact that Vertica copy command is distributing that workload onto the Vertica cluster instead. So if we jump into this one, we have a configuration-based job where every table entry that we want to load into Vertica is an entry inside of the config, and that entry is passed into an adapter factory, which creates our Vertica load adapters. This architecture follows the observer pattern in order to enable these managers to manage state, push real-time telemetry, as well as notifications. In this case, the adapter is the observable, and all of the managers are the observers. That upload manager in the middle implements a two-phase commit pattern to mitigate any state management issues that we might run into during failure race conditions. So we can now see how our data is loaded into Vertica, but we don't yet know how we maintain those tables. With this, we wanted the ability to version our database and track all schema changes, as well as a tool that we could build a deployment pipeline around. We tested 3 different options for tools, and we also considered creating an in-house solution. These tools being Liquidbase, Flyway, and Skitch. We ended up deciding to go with Liquidbase because although the Vertica keyword support was limited, it was more than sufficient for our use cases. And the other tools actually, they had no Vertica support at all. What we ended up using for Liquidbase is the XML changelogs, where we can generically accept SQL through SQL tags. You can think of this changelog as a history file, which explains exactly what has happened in the past, as well as what will happen in the near future. The changelog will be managed by GitLab in our pipeline and then processed through Liquidbase. And this is how we keep Git and Vertica in sync. Our CI/CD pipelines will be spun up on any commits into our next branch or our trunk branch. Commits into next will deploy that changelog into our development and staging cluster, and then commits into trunk will deploy that changelog into our Vertica production cluster. There's a lot of other considerations that go into this: monitoring, centralized logging, authentication, table and projection construction. How do we deal with query performance, load performance, saving disk space, cluster settings, and more? There really is a lot of topics, and we can't even consider getting through all of them. Now, this is nice and all, but as Catherine pointed out previously, the traffic flowing through our exchange is constantly growing. And in order to meet our growing scale, we must always be thinking of the future. With this, we have a next-gen architecture. It's currently a work in process, but a goal of this future architecture is to move majority of the processing towards the edge in order to lessen that bottleneck of doing everything inside of our Toronto cluster. Again, we'll zoom in. These regional data centers. Previously, it was just the ad server and the raw logs, but now we'll be spinning up some local Kafka topics for the raw logs as well as other business needs. Then we can do pre-aggregation of the data in local Kubernetes Spark streaming jobs. Some of the benefits of this include, one, well, you decrease the overall memory footprint required to process an entire data set. And this is because you're working on much, much smaller windows of data. Secondly is capacity planning. When we're in consideration within a rack in our data center, by default, whenever our exchange goes to grow by adding new racks, so too does our processing cluster. Next up, that existing Hadoop processing cluster will need to transition into 3 separate clusters. The first being Kafka. We're looking to use it as a central data hub for all sources and outputs of data. By using Kafka between our jobs, we can introduce a much looser coupling as well as an increased scalability instead of staging all of our intermediate data onto HDFS. Secondly, we'd like to have a Kubernetes processing cluster. We will still have Spark streaming in the Toronto data center, but majority of the heavy lifting will now be outsourced into our regional data centers. As we move towards Kafka instead of HDFS, it also simplifies our transition of moving to Kubernetes instead of running in Yarn containers. And lastly, a Ceph cluster. This can be used for easy-to-access storage of our log data outside of those streaming windows. On top, we can build a metastore for SQL access or a sandbox for Jupyter and Zeppelin notebooks. This can help enable our power users to troubleshoot ongoing production issues, mine raw data to create custom data sets of value, and really just test building business insights. Lastly, we're investigating BI tools that can be spun up on top of our brand new warehousing solution. Thank you everybody for taking the time to hear out our past, present, and future architectures. I hope this has been of value to you, and please come back next year to hear where we've gone with our learnings. And with that, I'm going to hand it back over to Catherine to wrap things up.
Thanks so much, Raman. So if you're interested in working on really tough data problems and bringing transparency to advertising online, please consider joining us. We're hiring for both a senior data engineer and senior operations engineer. If you have any questions about this presentation or about potentially applying to one of the roles, reach out to Raman or me. Here are our email addresses and LinkedIn links. Thank you so much. Looking forward to connecting soon.
Right. Well, we have Catherine and Raman joining us, and I think someone from Vertica as well, in case anyone has any questions for Vertica. Guys, I just want to say what a great presentation. Like, just the fact that you were able to share all this information with everyone, I think is super valuable. We do have a couple of questions. I'm going to start with the first one. That's about, does the solution analyze data in real time?
Sure. I was kind of questionable on what the solution represented. I wasn't looking at the exact moment in chat it lined up. Is this specifically asking around, does Vertica provide real-time analytics? Or Probably. Is this surrounding our architecture?
It's probably about the Vertica.
If so, I can defer it to the Vertica representative. Kurt, so before he hops in, I can mention that in terms of actual analytics within Vertica, we haven't yet built anything out internally. Not to say that that isn't a feasibility, but we're still early in our Vertica journey. If you have something to add, feel free.
Yeah.
Sure. Yeah, sure. This is Andreas from Vertica. So in terms of real time, analytics, I guess it really depends on what your definition of real time is. I came from the high frequency trading space, so real time is a little bit different than the typical customer or exchange use case in some ways. But Vertica has over 650 different analytic functions, as well as the extensibility to import models, for example, that you built in TensorFlow to score incoming data that's ingested into the system. So, and just a final thought, it depends on what real-time data is. Typically, when people talk about real-time data, the window of definition or analysis is rather short, as opposed to historical data where the window can be a couple seconds or a couple years. So I guess we just probably need a little bit more detail around the question, and we can dive deeper at a later time.
All right, thank you for providing your answer.
I could add one little thing on top of that. If the solution they were talking about was specifically how we're implementing loading, as well as the implementations we have built on top of Vertica, our existing pipeline to load the data into Vertica is batch currently. But as we move towards the newer architecture, we can use Kafka syncs, so Kafka connectors to get the data.
Right. And I actually have a question on my end. I'm curious about you guys as an end user. Like, how long did it take you from, I guess, implementing Vertica into your company to getting the results? And how secure was it, like, against the clickbait or the fake articles?
In terms of how long it took from an engineering standpoint, we began the planning phase within April, and this consists of everything along the lines of getting the licensing set up, getting the hardware in place, figuring out timelines between our operations teams, our engineering teams. All in all, it's partway through April, and we went live to all internal employees with SQL level access mid-August.
Wow, so not that long.
It was pretty quick turnaround time, honestly. I was pretty happy with the results. I'm not sure if that was an accelerated timeline due to being within the COVID times. Mm-hmm. In terms of how secure is the solution against fake articles and clickbaits, I'm not entirely sure.
I can take that. I would say, Raman, do you have anything else to say, or I can kind of?
Oh, you can totally take it.
So I would say that they're they're decoupled kind of. So like our Vertica database is more to like track analytics after the fact. But it is a really interesting question. It's like, how do we protect ourselves from like bots on the internet, or, you know, you may think of like belly fat ads, or ads where you see like, oh, like this celebrity got like 75 nose jobs or something. And we have a number of protections in place in order to prevent that activity from happening. So we don't actually end up recording it, because we have a couple of guardrails in place. The first is all of the advertisements that try to enter our exchange are go through a couple of auditing processes. We use a company called the Media Trust, which scans advertisements. And we also have a team of like 50 people who QA advertisements to make sure that like what's showing on the actual ad itself clicks through to the appropriate domain, that the ad is like the. And we also work with companies like White Ops, which is like an ad fraud detection and bot company, to make sure that the supply that we're onboarding, so the supply being our publishers, are like clean publishers. And we kind of pride ourselves on having like human relationships with the publishers that we work with, and auditing the supply before we onboard it. So we have a number of things in place, and that's sort of more just like our company philosophy. And then it does trickle down to just having cleaner data, because those are like quality standards before we actually ever even work with a company.
Right. Okay. Well, thank you for clarifying that. And I guess this question came in, and I guess it's more for like maybe from your own perspective as an end user. Like, did this have you guys seen maybe results in helping your clients reach their target audience, or increasing revenue from the advertising, like as a result of using this technology that Vertica is offering?
Yeah. So this access to data, just right now, it's mostly internal, but it's empowering our teams to sort of make decisions faster. So I actually saw an example today that's kind of perfect to touch upon. We had a deal running in Japan, which basically means that an advertiser has a certain amount of budget that they want to target across different media sites. And admittedly, I don't know the sites that they were running on in Japan, just because I'm not super familiar with the Japanese media landscape. But we have a team in Japan that was managing it. And because we have a lot of data and reporting about these deals, and we work with our advertisers to make sure that they're targeting the audiences that they want, we just saw that they actually doubled up on their deal, and like doubled the amount of spend that they initially intended. So that's sort of an example of having this type of data available to our customers helps us be more successful as a company.
Awesome. Well, on that note, thank you so much for joining us. We really do appreciate it. And I hope you can also stick around maybe even tomorrow if people want to reach out for any questions about your experience. And I just want to remind everyone, you can always visit the Vertica booth by clicking on the virtual booth tab, and you can always directly chat with one of their reps, and they'll be more than happy to help you with whatever challenges you are facing. So thank you. And I love always hearing from an end user perspective. And yeah, I hope you have a great evening.
Cool. Thank you so much.
Thank you.
Thank you, guys.